Hello, welcome to Science Shop, and today we're going to be looking at refraction basics. Now, if you've ever filled up a glass with water and you have a straw inside the water and you look at the straw, it looks like kind of like the straw is broken even though you know it isn't. Now, this is to do with refraction. Refraction occurs when light changes direction going from one medium to another. Think about it like this. Instead of light, let's have a car like so. And imagine you got tarmac all the way out here, and in this patch over here you have some sand. What's going to happen is the car hits it at an angle. The inside wheel slows down, causing the car to turn like this. And then it continues like that. And then on the other side, this wheel over here, it speeds up, so it changes direction like that, and it goes off like this. So the overall direction is like this, changing direction like that, changing direction like that. That's kind of how it goes. Okay, let's draw a few diagrams just to help us. And there's a little thing that I use. It's called tag agar, and I will explain what this means in a moment. Tag agar. Okay, firstly, let's imagine this medium is glass, and over here you got some air. Okay, let's draw our light ray. So suppose our light ray comes at an angle. Oh, before I do the angled one, if the light ray comes in straight like this, there is no refraction. It just goes straight all the way through. Refraction only happens, as in the light only changes direction when it comes in at an angle. So let's draw one of those light beams just to see. Okay, so I'm just going to pick a random angle, and it's going to be like this. That's our angle that light goes in. Okay, now the first thing that we've got to do is we've got to draw something called a normal line. Now the normal line is a sort of imaginary line perpendicular to the surface of the glass here. So let's do that. Okay, so it's always at right angles, and this is what we measure the angles off of. So I'm using the set square so I can draw this right angle fairly easily. And I'm doing it as a dotted line. And not only that, I'm going to extend it all the way down here as well. I'm kind of rushing, so it's probably not perfect, but you get the idea, okay? I'm going to label this as the normal line, okay? What happens next is this, okay? I've written tag agar over here. Or what does that mean? Towards air glass, away glass air. So if it's going from air into glass, so in this direction, it should be going towards the normal. So the light ends up, instead of continuing like this, it bends towards the normal like that. And I'm going to extend this beam of light all the way down to the bottom over here, like so. Now, once it hits this boundary, okay, we can draw another normal line to show what happens afterwards. So again, at 90 degrees to the surface of the glass, let me just put it up like this. If my video skills were better, I would fast forward this bit, but I don't know how to do that, so I don't. Okay, anyway. So it got like this. Now it's going from glass into air, and it's away glass air, as in away from the normal when it's going from glass into air. So let's draw that. So that's the normal line. And instead of continuing like this, it now refracts away from the normal. And it's actually good practice just to try and get it like parallel to the original line like this. Okay, don't need to do it dotted. There we are. Okay, so the next thing is to label all the different parts. Okay, So let's get my pen out here. So this is something that we call the angle of incidence. So that's that angle there. And this angle here, this is the angle of refraction. Okay? So you've got a couple of angles. You've got that angle here and that angle there. Okay? Again, over here, you always measure it from the normal. So that is your angle of incidence, and this one over here is your angle of refraction. Okay? Now, the amount that the light changes direction is dependent on something that we call the refractive index, or N. Now, the refractive index for air is 1. Okay, it's actually 1.0003, but we'll call it 1. For glass, it's about 1.52. And for something like diamond, it's 2.42, which means that diamond will refract light more extremely than glass will. Okay, so instead of going down here, it'll go even more towards the normal in this case. Okay, so that's refraction basics in a nutshell. Hope you understood it, and I'll see you in the next video. Goodbye.